We're approaching the part of the course where we start dealing with the routing table. That's coming up pretty soon. We've got connected routes. We're going to work with OSPF a little bit. We're definitely going to do some static routing, static and default static here in version 6. But before we do that, of course, what are we always going to do once we have new routes in the table? We're always going to want to test them with pings and maybe even a trace route or two. So before we do any of that stuff with the routes, we need to look at how pings and trace routes work with version 6, and you will be very happy to know that they work really exactly the same by default as they do in version 4. You're going to use the same commands, you're going to get the same returns, hopefully good ones, and I'll also show you a little deal with an extended ping. So let's go ahead and jump back on the live equipment, and I will run a show interface fast 00 just to show you where we are now as we've moved around a little bit. Router 1, why aren't we seeing version 6 stuff there? Because I didn't put version 6 in the show commands. See, I told you it happens to everybody. It'll happen to you one day too. I can hear somebody out there saying that is never going to happen to me. Forget it. Forget it, my friend, it is. So you see the global unicast address here of router 1's fast Ethernet 00 interface. That's an address we've worked with before here in the course. And here's another one, this one be ending in FEA4, F4A0. And they're on the same subnet. So we should be able to send some pings here between the two with no problem at all. And there's nothing else tricky going on. I haven't configured anything else. What we'll do first is go over to router 1 and see if it can ping router 3. And what we will do is copy this global unicast address on R3. And that's not just being, well, I don't want to type all those numbers. It's easy. Let's face it, the longer the address, the more characters you have, the larger the chance of a mistyped address. So what I like to do, if you have access to the router that you're going to ping, just copy the address. Do a mark by right-clicking, then left-click and drag, and then right-click to copy. It takes a little getting used to at first, and there are other ways to do it with the menu and the window you're in, that kind of thing. I just like to do it this way, and again, sometimes, yeah, you can't do it on this one. Occasionally, you can go ahead and copy it just by click and drag, but what I like to do again is right-click, select mark, then left-click, drag it over what you want. Takes a little practice, and then just right-click, and you have copied it, even though you're not going to see copy on there. So let's go over to router 1, ping, and then just do paste. Pretty slick, huh? Let's go ahead and send that over, and we see exactly what we would see with version 4. 5 100 byte ICMP echo packets get sent to the address. We got them all back, and life is beautiful. I'm going to go ahead and run an extended ping here too. We only did that once in this course, and that was to change the source interface of a ping. And on occasion, you'll want to do this in specialized lab situations like that one. But what you can do here is do an extended ping. Just type the word ping and hit enter. Then you need IPV6 here. Then it's going to ask you what the target address is. And if you've copied it, you can paste it. And then here you can just go ahead and accept all the defaults. We don't need the extended commands. In the other video where we used extended ping, I said don't just keep hitting the enter key too fast, because if you're changing the source interface of the ping, you do need to go into extended commands. Here we're not going to do that, so we just took all the defaults and everything is just fine. The escape sequence to abort, that very important escape sequence of Control-Shift-6 twice, that is exactly the same. So if you were sending 100,000 pings as part of a lab work, and after 5,000 you say, okay, I got it fixed, you don't have to wait for the other 95,000 pings. You can just do Control-Shift-6, Control-Shift-6, and you're out of there. Now we don't have much to trace route here, but we're going to go ahead and run one so I can show you what that's going to look like. I think we're going to have one address here. Yep, and that's it. Not much to trace there, but obviously as your labs get larger, this gets to be a very important command. And again, Traceroute is going to work the exact same way that it does with version 4. It's going to go hop, 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 hopefully, and just keep showing you the addresses of each hop as it goes along. And should you get stuck, should you start getting all those asterisks, you don't have to watch 30 rows of asterisks. You can just go ahead and do the escape sequence and you are done. That's really it for ping and traceroute. Again, nothing real fancy here. And I will go over to router 3, and just for fun, I always say just because A can ping B, it doesn't mean B can ping A. And that is true in rare cases. Now here it would be really rare because we don't have anything else going on. We can send that ping from router 3 to router 1, it goes right through, and everything is just fine. Before we go to the next video with those particular routes, we're going to start with connected, and I'm going to introduce you to another kind of route here in that video. What I want to do, I don't want to drown you and show IPv6 video our commands, because we have a lot of them, as you can see. But one I really would like to show you right here is neighbors. And you'll notice, these are both at the same neighbor, fast Ethernet 00. And you can see the MAC address is the same. So that, of course, is another tip-off. But this is another great way to say, okay, there's the address I want to ping. You can grab it there too. So just another little bit of information there. I'll give you a little info about that command, or what we read there as well. Hold on one second. Let me catch up there. Yep, here's that command. And it's going to be too big on here. The formatting's off, so I'll bring it back up. Now, the IPv6 address field, that is self-explanatory. Age refers to the last time in minutes that the address was reachable. And static entries are going to be represented by a hyphen. And you see we actually have zeros there, so it was less than a minute. Link layer, that's the MAC address of the host. That's all you need to know. State, we're not going to go into here because it is way beyond the scope of the exams. If you want to dig into that, it's easily findable on Cisco's site. I did put the URL here, but it's probably easier if you just Google the term and look it up that way. And then interface refers to the local interface through which the neighbor is reached, but it does show their MAC address as well as their IPv6 addresses. So that can be a helpful little command at times. Now, about those routes, with version 4 and version 6, there are no routes in the routing table by default. We know the deal. We've seen an IP version 4 router from scratch. We've opened it up, put it in our lab, etc. And the interfaces are all shut by default on a router. So, of course, there can't be any routes in the routing table by default. But even when you open the interfaces, there aren't any routes until you put IP addresses on the interfaces. Once we do that and open them, what did we see? We saw connected routes. But with version 6, we see a little something different. And let's go ahead and cover it in this video. We see a little something different. It's called the local route. And if you're using my study guide, what I've done here is deleted the route codes from the table except the ones we're currently discussing. But on the live equipment, let me go ahead and show you these codes. Now, why aren't I seeing anything here? Because I typed in show IP route, which is the version 4 command. I have to put in V6. It's going to happen to you. Happens to everybody. Just be careful. Just realize, hey, don't think, the one thing I don't want you to do is jump to the conclusion immediately of, oh, I did something wrong with my config. You didn't do anything wrong with the config, you just forgot the V6. It happens. Now here's the V6 routing table. Isn't this cool? It even tells you how many entries you have. Just in case you don't want to sit there and count your entries, it's already done it for you. But much more importantly, it's got the usual code table here, of course, with some differences. And we're not going to go over all these route types in the CSET or even the CCNA, as I'm sure you're glad to hear. But we are going to talk about connected local static, and also a little bit of OSPF. We're not going to get into all the OSPF that we did with version 4. That was enough, but I want you to get a taste of it. What we're interested in here, though, more than anything else really, is the local entry, because connected routes, we had those in version 4. We saw those every lab we did. And we worked with static and default static routes quite a bit in that section of the course. But now we've got this local route. And notice we have 2 entries. Now I want you to just ignore the null 0 route for now. Just ignore it at this point in your studies. What I want you to pay close attention to is this entry, because this is kind of odd, because notice the prefix and notice that it seems to be a route for one specific destination. What do we call that? We call that a host route. Now, a host route would have a mask and prefix notation of what in version 4? It would be a /32, but in IP version 6, of course, it's /128. Well, here's the thing. You and I didn't put that in. All we did was open the interfaces, put addresses on them, open the interfaces, and that's it. And then all of a sudden we have this local route. Well, what happens here, that is, as we call it, the desired and expected behavior. That's a fancy way of saying that's what's supposed to happen. The version 6 router is going to put the connected route in that we expect, but it also puts a host route into the table for that segment. And in this case, it's router 3's interface on that same fast Ethernet segment. That's just the behavior of version 6, and we do expect to see it. So do not freak out and say, hey, wait a minute, I didn't put these local routes in. They're going to be in there by default. When we start the next video, we are going to pick up with static and default routing. And again, you'll be very happy to hear that just as ping and traceroute were much the same between the two versions, 4 and 6, static and default static routing work under the same basic principles in version 6 as they do in version 4. Obviously, we just have to get used to a slightly different syntax. So I'm going to set up a loopback on router 3 for us, and then we'll do some more lab work in the next video. See you there.